It's a bit gluey. Okay. So let's inspect it. We have a lot of hot glue here. Let's try to refocus. What seems to be a lithium cell. No markings on this side, at least. And some hot glue here holding this circuit board in place. Interestingly, we have actually a connector here. So let's try to zoom in a bit on that. I mean, it does feel a bit yeah, what should I say? If this hot glue lets go, maybe some components can be shorted out. I would put some hot glue in that case on everything here, in case this falls off, so that nothing touches the metal here. And maybe there's a plastic or something coating here, I don't know, but interestingly, this is a modular circuit board, and so you could take it apart and take the LEDs and stuff and implement it in a project of your own. It's a pretty strong adhesive, actually. So taking it apart just like that isn't that easy, maybe. It's pretty solidly in there. I mean, this doesn't move anywhere, so that's good in one sense, but getting the cell out is, in that sense, it's not too good. Of course. But what we can do is we can at least measure the amps that we draw from the battery. So let's do that. So I have set this ammeter up, and currently the light is turned off. So let's turn it on, and it's showing about, in a pretty low setting, about yeah, 0.10 amps. And then if I hold this to increase to maximum brightness, we're up to about 340 300 milliamps. So it does vary a bit, and this is in the warm setting. So if I go to the cold setting, yeah, maybe we need to measure. I believe we have 2 wires that we need to measure, because we have 2 rows of LEDs in these settings. So let me try that. Yeah, so with 2 wires attached to the ammeter, and in the mixed mode with all the LEDs on at maximum, we're about 0.37 amps, 0.38. So and we'll go to the minimum mode. Yeah, in the lowest setting we're only about 80 milliamps or so. So yeah, there's quite a bit of a difference than which we saw in the battery test, or the runtime test, that it differs quite a lot, the runtime between maximum and if we only go halfway up, then maybe we'll land somewhere at around 17, 19, 20 200 milliamp hours, sorry, 200 milliamps of power draw. So effectively doubling the time we got. In the first test we got about 3 hours, but then the light was very dim at maximum setting, and then in the second test we got 6 or 7 hours of runtime, and so it seems to be correct. Okay, very interesting. However, the connector here makes it. I mean, I would suspect that. Oh, sorry. That there would be like an 18650 cell inside, or something like that, but it really wasn't. But on the other hand, so you could take this connector and cut those wires and then attach them to maybe an 18650 holder, and then you could get maybe 3,200 milliamp hours or so in the battery, and then connect those leads to that holder and place it inside, or even maybe a thicker battery. So an 18650 isn't the largest capacity one either, so that would be quite interesting. So I wonder, yeah, there is let's try to focus. I believe there is protection circuit at the battery side there, but getting this battery won't be easy, so I have to think about it for a moment. So after quite a bit of a struggle, I actually finally did manage to remove the battery cell, and it involved removing a lot of hot melt glue, but this is the glue was very good in the sense that it made the entire assembly sit there very strongly attached. So yeah, but finally I did manage to pry it off without any damage to this cell. These marks on the cell, scratch marks, were there before I started, so yeah, without the cell we have the circuit board, and it has a USB connector that just sticks up here, protrudes here, and so my idea is to, yeah, first of all have a look at this cell, and there is some kind of a chip on there. I'm not sure exactly what it is, but then we have this connector, and if I'm not mistaken, this might be a micro GST-PH 2.0 connector or something like that. And instead of destroying this cell, so it doesn't have any markings on it, with respect to capacity or anything. So what I would like to do is to maybe remove this goo and this circuit board, and then why not get maybe I don't know, 18650 or 26650 cell and a holder for it. Maybe get a lead with this correct connector attached. I believe it should be available on AliExpress or something. And then attach the lead with that connector to the cell holder with the cell, and then put that inside here and get a cell with a protected circuit as well. And yeah, maybe we can then extend the life of this the runtime that is of this lamp. So I will try to order some stuff, and since I don't have it readily available, and it will take a little bit of time, but for you, of course, it won't take a lot of time. So I'll be back in a moment, but for me it will be a few weeks maybe before everything arrives. But yeah, this cell unfortunately isn't too large, and it's only 750 milliamp hours. So yeah, see you in a moment. So this is the dining table I was talking about previously, and it's kind of a dark spot here. It's not completely dark, but it's not very bright either, even during daytime. And now it's about 2 o'clock in the evening, in the afternoon, I should say. So I have a ceiling light here, but when lighting candles, it can be quite cozy. And however, the very end here of the table, closest to the wall here, it gets pretty dark. So that's my initial idea, that it would be nice to have some kind of light here, but I don't have any outlets here, so a battery powered light would be nice. And now that I have removed the battery cell, I can confirm that we can run this light without a battery. If we have a power bank, for instance, which I have here, so I can turn it on, and then if I tap it, yeah, it looks pretty cozy actually. So this is more what it looks like to my eyes. So yeah, it looks good actually, and it works pretty well even without the battery. But then I will have to have a power bank or something and some cable going somewhere. So we should try to fix the battery capacity problem in some other way. So let's look at that next. But at least it runs off of a power bank, so without a battery, so that's pretty nice. If you don't want to have a battery that will get swollen after some time, then yeah, you can just remove the battery cell and then place it near your bedside or wherever. And if you have a USB connection to your computer or a USB charger or something, and then you can have a smart power plug or something, turn it on and off. So it looks pretty nice actually. So yeah, but let's look at the battery replacement part of this now. So some time has passed since the last time I had a look at it, and well, it should come as no surprise that I want to mod this. I have tried to straighten it out. It wasn't very straight. I have tried to straighten it out a bit, and it seems to be fine. There's like a bolt here, and it holds the assembly together. This bottom plate here, it sits here with just some glue, and I think that, well, we shall try to remove this glue, and then we will fasten it back with some new glue. And the battery cell here, which I managed to remove last time, it sat here, and I managed to peel it off. So we'll put it here, and then yeah, the idea is to put a better battery inside of here, and remove this glue here, peel it off, and maybe remove the circuit board and see if we can fit a nice fat battery inside of here. So I have since last time I have been waiting for a couple of things to arrive, and also planning a bit on this light here. So I have a mystery box from AliExpress, and let's see what's inside. There's a lot of stuff inside. First of all, we have a plastic bag with what seems to be connectors that look like this. I believe this is the JST 2.0 connector, maybe, and hopefully it's the same as this one from the original battery assembly, because I want to be able to connect it here, but only to another battery than this one. So yeah, let's put that here. I also have a couple of other things, and one of those couple of other things is this Nightcore NL2145 4500 milliamp hour battery, lithium battery, 3.6 volts, 16.2 watt hours. Now this is a 21700 class battery, so it means that if I'm not mistaken, it should be 2.1 centimeters thick in diameter and 700 millimeters long, right? So let's see what it says here. Yeah, it doesn't say too much. Not discharge below 2.75 volts. Let's see if I can focus. Or charge above 4.2 volts. But this one should have some overcharge. Let's see here. Overcharge and discharge protection circuits. So this one should cut off at 4.2 volts when we charge it, and at 2.9 I suppose when we discharge it, maybe. I suppose that this maybe the circuit board here has some chip and stuff for charging. Maybe it also controls it, but I think I hope it won't interfere with it. And I haven't opened this up yet, so it's brand new in box. Right. I also have a holder for it, which I hope will fit the battery. It seems like it. It says, let's see here, if I manage to focus, it says 21,700 about there. We have the positive and the negative, and then we have some protruding bits here. So we'll see how we go about this, but yeah, and then I also have a little box here with some extension USB-C leads, and yeah, my thought is that so I have different kinds here, and my idea for it was to remove this circuit board and maybe gluing it in place or something on this bottom plate, and we will also perhaps place this one on the bottom plate and then place everything on top. I don't know if it will fit inside or if it won't, but we will notice that as we go along. And this is probably the maximum size cell you would fit in there, I suppose. This is substantially larger than an 18650. So for comparison, we have a standard rechargeable nickel metal hydride AAA battery. So yeah, it looks tiny when placed next to it. Or we have a 9-volt battery, which looks like this. But do I have an 18650 here? Maybe I don't. Oh well, it doesn't matter. So yeah, so I have some stuff, and removing this board, then if placing it on this board instead is possible, then using an extension cord to connect that to the hole here, so we can have some slack here a little bit when we open it up, and because if I remove this board, I think that we will be able to have a greater chance of actually fitting this battery and the holder inside here somehow. So right now things are in the way a lot, so yeah. Alright, but what I need to do is to first of all, let's check this battery cell and pick one of these leads here with the connectors prepared for on the wires already. So I can see that, let me just refocus. It's visible that the wires are not sorted or ordered in the same order from left to right. So the positive here is on the right, but the positive, or the red one here, is on the left. And if we turn it around, yeah, they're the opposite direction. So and I have measured this battery. The positive is the red one. We can double check it because you know, lithium batteries. So let me just fetch my voltmeter and we shall have a look. So voltmeter has been fetched, and it should be plenty visible there. So let me just remove the caps here. We'll set it to DC volts, and I will try to probe these without shorting everything out, which might turn out to be harder than I thought. Yeah, 2.895 volts positive. So the red on the red and the black on the black. So yeah, this is a pretty discharged lithium cell, and we should charge it up at some point if we plan to use it for something. And I have some ideas, so we will not throw this away for now. It can be here. And yeah, but what I need to do then is to, let's see here, where did I put, yeah, this lead. So let me just put this aside, the voltmeter. I would like to swap the positions here so that the red remains the positive. Let's see if I can do it with a bit of help from and also trying to stay in shot. If I just lift this tab a little bit, then I can pull this out, and it's going this way with the like this. And then I will do it the same thing with the black one. If I manage. That is. Yeah, and then I just reinsert it there and press the tab here a bit so it stays in place, and then I grab the red wire and it should be turned this way, and I go about yeah, and I can press back the tabs. Yeah, so these GST connectors kit bag, I believe I bought it from, was it Amazon or was it AliExpress? It's a 10 pack, so and you get the connectors on the other end as well if you need to. It cost a few dollars, nothing to worry about. This connector was pretty cheap as well. It's nothing special about it. It's a holder. 21700 holders are not as common as the 18650 holders and stuff, but they're common enough, and it costs $1 or something like that with shipping. Now the 21700 cell here, on the other hand, since I bought a Nightcore one, it's a pretty expensive brand for Chinese brands, but they should be good as far as I'm aware. And it has some weight to it, and it cost
Oof. Now I forgot to check, but this was in the range of, was it maybe around $20 or something like that? Somewhere in that range, plus minus $4 equivalent. So yeah. Yeah, but okay. Now that we have done this, let's see if this actually fits in here. Is it the correct connector? If it's not, then it's not. Then it's a bummer, but let's try it. Yeah, it seems to fit there. Yeah, good. So that has been prepared. Now what I want to do is I want to, oh yeah, I want to remove this circuit board, since I want to make room for the larger cell. We have a bit of slack here, as we can see. We have a ground, no, we have a, yeah, the touch button here. It has a wire also that goes to this circuit board. We could of course make it longer, but let's see if maybe it's enough anyway. And I will try to remove the gluey goo here, or gooey glue. I don't have to remove this glue maybe, but okay. Let me get rid of this stuff. All right. So the circuit board would be nice to have somewhere here. And then yeah, this wire is a bit short, maybe I should make it longer. And it's just soldered here. But let's check then. I have the USB-C here. Let's see if these extension cords actually work like I plan to. So this is the longest one, and the short one, yeah, the short ones are a bit short. So let's oh yeah, and these cables were not the cheapest either, I realized. Not too worrisome, but they were a couple of $3 or $4 each. But they're very silicone, and I hope they are good. So yeah, I should connect this end. Let's maybe zoom in a little bit. this end in there, and then this one should go there, and I would have to, oh sorry, and I will have to glue it in place. Hopefully normal hot glue will work. So yeah, something like that. And then of course, if I remove the coating here, I could make it protrude more through this hole here, and then glue it in better. Maybe I should use some UV resin or something like that, which I don't have at the moment, but so we'll just try it for now, and then if I need some UV resin, then I have ordered it, but it hasn't arrived yet. Okay, but what's the next step then? Well, I want to remove this glue. Okay, much cleaner around the edge here. So yeah, I think that this extension lead is the way to go, and however, maybe the other ones are long enough, but yeah, we'll notice. Okay, so oh yeah, so this one then, will this fit in here? I'm thinking that these tabs here on the sides, maybe I should fold them around the side here, at least to make them flat, like that instead of like that. So maybe I can solder the wires to those tabs, and then now I can place it flat here like this. But then the question is, even if I place it on around the middle part here, it's not completely flat. I will have some trouble, I believe, placing this on top. So let's say I have crammed everything in there. Yeah, there will be a gap like this, and that's not good. However, yeah, maybe it's these tabs here that are too long. Of course, I don't want them to short out. I mean, if these are too short, then they can... I can place some hot glue here on top, of course, instead. So I would need to cut this off a bit. And maybe it will fit then. That's something I really need to do, I suppose. Yeah. To make it fit. So the problem is not the length, maybe, but the diameter of this cell. 21. I'm glad that it didn't go for the 26,650 cell. It's 2.6 centimeters thick, and this should be 2.1. But still, it might impose a problem on us for this project. So let me grab my electronic side cutters. And what if we just remove a bit here? Of the upper tab area. So something like this. So I suppose that is to make sure that this doesn't short out to the casing. But if I place some hot glue over here, then once I have installed the battery, then it shouldn't short out. So yeah, let's say we have something like this. Would that... Ooh. It just might. It just might work. I lost a little bit of light, but I think we should be okay for now. And actually it's the corners here that are stopping us. Since this is sort of dome shaped, if we cut the corners here, yeah, cutting corners, that's what we do here. Ooh, that flew somewhere. Yeah, something like this, and then if I do pretty much equally on the other side. So something like that. Okay, let's see how it would fit inside now. Yeah, I will try to place this on top. It almost fits. Almost fits. That's Almost. I shall see if I can. See if that makes any difference. Yeah, you know, almost, I suppose. I would have to. Yeah. So what should I do about that? Let me have a think. So I have given it some thought. This looks pretty flat, but it does move about here. But I'm thinking that what if? I mean, I will place it sort of in the middle like this, and since the gloop is placed on the rim here, if I place like a fatter, thicker layer of hot melt here, then maybe it will give it enough room to actually fit in there. So let's go for that for now, at least. And yeah, since this will be glued somewhere here like this, I will solder some the leads from this cable. Oh, I actually hope they, yeah, they do reach, but it's gonna be a, yeah, okay, it will be a stretch, but okay. And then this one will be, so if this one is in the middle, I can place this maybe flat here somehow, and then use the extension cord for USB-C. So maybe, yeah, but I do need to prolong this or extend this cable for the touch button, so I shall desolder that here, and then we will extend it a bit, I think. Okay, so things are being prepared here. The soldering iron is turned on. I'm using the non-USB version, but one that connects to the outlet, to the mains. And I have a desoldering pump here, if need be. And yeah, let's try to, oh sorry, I forgot the microphone. I shall put it on me. Let's put some solder, some tin here, onto this one and see if it's ready. Not quite, it seems. And I will attempt to let's remove this for a second. Maybe I should bring in these small helping hands. Just to make things hopefully a little bit easier for me. Okay, so and we should zoom in a bit, is my suspicion. So what about 3 times zoomed in now? Let's see if this works now. It's starting to. So yeah, let me attempt this. Okay, it's not hot enough yet. Okay, it solved itself. Pretty well, it seems. So yeah, it looks fine over here. So this lead, let's see if we can extend it. Yeah, so I have a cable lead here. It's blue and not the same gauge, but hopefully it will be fine. And then I have bought a little pack here of shrink tubing, and let's see here if this would possibly fit. So I have a, I believe it is the smallest. No, there are thinner dimensions, but let's see here what this would look like. Yeah. Yeah, sure. And then doesn't have to be this long, of course. So I can cut this. I suppose I can cut it in half or so. And then this wire doesn't have to be this long, of course, but it might as well be. So let's just cut this off there. This is from an old fan, I suppose, I believe. So yeah, let's try to yes. This is a bit thinner wire, but I hope it should work. So one end will go there, and one end will be soldered to the circuit board. So yeah, I shall strip a little bit of the cable from this end as well. And let's now let's turn around a bit, refocus, and tin this. And also this one should be tinned, so let's do that. Place a little blob here. And then I will just yeah. Oh, it's good I had this new mat, because as we can see there, a little blob of solder actually fell, and yeah, it seems to be working nicely. This mat was pretty cheap. It wasn't many dollars. There were cheap, more expensive models with all kinds of stuff. I believe I bought one of the cheaper ones, not the absolute cheapest, but this one has got some compartments and stuff, and some magnetic parts to it. So okay, that's been tinned. Let's do the other side. So I will oh, I have some kind of a blob thing going on here, but it got tinned. That's the important part. So it looks like this now. Pretty good, I think. We'll put that aside here, and I will try to tin this one over here. So let's zoom in a tiny bit over there, and then I will attempt this. Yeah, it looks decent. Yeah. So now what I want to do is I want to connect these two pieces. So let me move the camera a little bit. I want to connect these pieces here by reflowing the solder here, and make a connection, and then I will use the shrink tubing to isolate them. So let's attempt this. I will start off by putting a little blob here. Blowing away some fumes, and then I will place this one here. and see what we got. So we got something. I can just cut away the excess part here. It was too long. Oh, lead here. So yeah, I shall reflow a little bit more here just to make it nice and smooth. Okay, hang on a minute. So, yeah, this looks better. And now I will insert this lead into the shrink tubing. I chose blue because this wire is blue. Place it over there, and then I will just gently use the side here of the iron to shrink this. This iron is pretty big and bulky for this. Maybe I should have used the USB iron. That would have been easier, of course. But okay, let's inspect. Yeah, this sits pretty snugly in place here, which is good. I seem to have a little thing here, but it doesn't go through the insulation. And now I need to solder this onto here. And since I have pre-tinned things, I hope, maybe it should be enough to just reflow. And I will place a little blob here. And there we have it. So, all right, that's that done. Now I have a little bit more slack to play around with. These leads aren't very long, but maybe they're long enough. So if I place this like maybe here, and then the battery, so I could perhaps glue that in place in there with some hot glue or something, and then it won't be in the way for the battery. And then I can hot glue this somewhere here, sorry, like this, so get as much space as possible for the battery itself. But before I do that, I mean, since I have the soldering iron hot and ready, maybe I should solder some leads, more specifically these ones, onto these tabs here. And let me just see what orientation I would like this to have. So I have the hole here, so maybe if this can be somewhere here, and then yeah, this cable should be inside, of course, something like that. Yeah. So in that case, yeah. Since this circuit board will be sort of flat here, and I will have this connected in this connector, and I want these leads to, let's see here, I have the negative, maybe I should place it like this then, the negative, so I can yeah, something like this then, and then it will be closer, so this should work, I hope. And the negative there, yeah. So let me try to, these are very, let me just, yeah, refocus. I don't know, these are very shiny, so I don't know if this solder will hold on to these very well or not, but I will give them a little scratch with this one. So in case you wonder what I'm doing, it's just to give the solder some surface, some good surface to attach to. It's a bit scratched. Okay. Great. So I might as well bring in the helping hands here, and let's have a look. So this is the negative. I shall pre-tin these if they are not already. Well, I might as well place a bit of tin. both onto the tab and then onto the wires as well. So I will a little blob there, and then I shall place a little blob over here. Yeah, that worked nicely. So I have blobs there now. Oh, I shall just remove the extra blob I got there. And then I shall tin these wires a little bit. Okay, and I don't know if they got tinned or not, but they didn't seem to want to accept it, the solder too much. But we'll try to attach them now. So I have the negative there, and let's see here. I wanted this should be connected there, and then the negative will be on the other side, so it will be something like this in the end. So let's solder the positive. Maybe I can solder it in this direction. Let's try it. I will require a blob. Let's inspect that. Yeah, it looks okay. And the negative side. Oh, I'm out of shot, am I not? And I will place it there. Something like okay, maybe I don't need the helping hands anymore right now. So let me just refocus. Right, so we got a nice connection there and a nice strong connection there, and we have the positive and the negative. And And then maybe we can hot glue the leads like this, and then it can go into, let me just remove some stuff here, then it can go into the connector here like this. So yeah, something in that order of things. So I don't think I need the soldering iron anymore. Yeah, so let's disconnect it and go for the hot glue gun instead. Alright. The pink little hot glue gun seems to be about ready. So let's try to... I need some more light here. Yeah. Let's just try to cram this in there like that, and place some hot glue. Yeah, so basically, let's grab the USB-C extension and connecting it there, just to see how much space that is needed for this lead. And it extends quite a bit actually. So question is, will this work? Maybe I need to use something like the 90-degree angle adapter instead. Because then I get the bend for free, so to speak, but unfortunately that lead is not as long as the other one, so it would make it possible to put it sort of there at the very edge here. I can of course try to glue it there first and see if I can make it go all the way there, and then glue this one in place here Yeah, let me try that. It seems to stick pretty well. Let's see. Oh, it was a bit close though to the edge here, because this dome-shaped thing here isn't really so allow me to undo this. But the glue did stick pretty well to the bottom plate. So I shall remove this. Maybe something like that would do. And then placing this one as close as I can after. Yeah. So let me re-hot glue this. Pressing it down a bit. That one should go there. Yeah, what if I remove a bit of the outer casing here? The black shrink tubing. Just to make it go through the hole for the USB-C on the lamp base a little bit. Something like that, maybe. Yes. That should be good. I think. Do anything else? Maybe I should try that. This works with the battery and all. So let me open up the battery. And put this aside. And first of all, let's measure the voltage and stuff on this one. I'll put this to DC volts. Let's see what condition this is in. 2.23 volts. Maybe a tad low, but it's not 2.9 or anything, so okay. But at least the lamp should light. So if I now, let's see here, hopefully I don't have anything shorted out. So will this fit in here? Oh, wait, hang on a minute. It doesn't particularly like to fit inside. Yeah, so maybe this holder did not account for protected cells or the ones with the little head on top. Because this one does not seem to fit all too well. That wasn't very good, was it? But what if I bend away the positive terminal a bit before I cut it off? I just bend it away. So what happens if I do it like that? It's still tight, isn't it? I would need to maybe press the negative terminal as well a bit with something. So since I didn't find any pliers, I have side cutters here. Let's see if that works. To press that a bit flatter. And let's see if it can fit now. Oh, it did fit. But the question remains. So this okay, so the lamp isn't turning on. So I'm not getting a contact down there, I suppose. Let me measure. So my suspicion is that I'm not getting a contact between the negative and the positive. Sorry. No, this is not the correct voltage. The correct voltage should be I don't. So this tab on the positive tab is not having a connection. Okay, that's not good. And now the battery sits there. So disconnect it. Yeah, it doesn't. Inside there, the tab doesn't touch the terminal on the cell. Oops, almost cut myself. So I managed to get the cell out, but yeah, as we can see, this isn't very good. I'm just trying to bend this back. Now let's say I have something like that. Will this fit inside? Yeah, it actually did. So let's check the voltage. So do we have a voltage on the tabs here? Yeah, 3.26 volts. We do indeed. So that's a start. Okay, but I'm starting to question the one thing though, at least, because this battery is a lot higher up here than the casing itself. So I'm starting to think that this won't actually fit. Or it might. Not too well maybe, but we'll give it a shot, I think. At least. So maybe I will have to choose another type of cell. But if I place it here with some hot glue, let me attempt to do that. And let's see here. Oh, I can see that my phone is running out of battery, so I will have to unplug my microphone, external microphone, and connect my phone instead. Alright, so now I'm using the internal microphone of the phone. Okay, this battery sits there, it's not going anywhere. And I will place hot glue on the tabs here as well, because I don't want them to short out anything. There, and on this side. Something like that. Now I did place this pretty close, so it will be hard to remove the connector, which was maybe not the best thing of me to do. Sorry, I'm out of shot, of course. I will zoom out a bit so you can sort of see what I'm doing. I'm just trying to get that connector to stay in place. By gluing it. Yeah, I'm completely out of shot, I suppose. But bear with me. Okay, let's inspect this. Okay, so I have the cell here, and I will place a bit of glue also on the terminals here, just so that nothing shorts. There and right there on the terminal of the battery holder. So as you can see, we have a lot of hot glue here. Oh, it still hasn't solidified. And then maybe if we can turn this way around. Yeah, we can unfortunately also notice that the battery, since the battery itself is a larger diameter, it doesn't really fit inside. That was something I missed a bit. So yeah, it's sort of moving about then. But at least it does work, sort of. Unfortunately, I will have to buy a smaller battery, I believe, for this, and yeah. So, all right. But everything else is in place here now. So, if I just swap the battery out for another one, then maybe, yeah, 18650, or is there some smaller size? I will have a look, and then we'll continue once we have everything that we need. So hang on a moment, and it might take a few days, of course, for me, but for you it should be quick. So a little bit of time has passed since I ended the last shot, and well, as you can see, I'm still here with the NL2145 4500 milliamp hour battery. And as I mentioned, yeah, we had a problem here where this doesn't really fit all too well. Yeah, my idea was to resort to removing this and finding a smaller battery, maybe an 18650. And I went online and started looking around, and ordered a couple of 18650 night core cells. But then I thought that no, that is not how this channel and the DIY we're doing here works. We cannot succumb to challenges. How do we make this fit into this? Well, it turns out that an idea came to mind, which was if I can place some distance ring of some height and glue it onto this rim here. Then I would add some thickness to this, and that would perhaps allow the size of this cell to fit in the base by simply extending the base. But where would I find a matching distance ring to glue on here? Well, I didn't, and that was a bit of a problem. But then I, after many years actually of having had an idea in mind, not for this project, but in general, I emptied my savings account and thought that why don't we solve the issue by getting one of these. And this is a 3D printer. My first ever 3D printer. I've been thinking about getting one for many years, but haven't gotten to it. And the upfront cost has been one factor, of course, but time and other factors also played a role. And yeah, so this is a Flashforge Adventurer 3 Pro 2 printer, and it should be able to print 15 by 15 by 15 centimeters worth of things. And I did load some filament, some black filament in here, and yeah, I liked it, and it was on a bit of a sale since it's the time of the year now, and I paid maybe $380 US equivalent for it, free shipping. And then I got one pack of filament, but I also have bought some filament. And yeah, I loaded in a black filament here, and since this base is black, and yeah, maybe that should work. So yeah, this is a $380 plus filament cost distance ring DIY problem solver. It's of course completely insane to, I mean, this lamp cost like $16 equivalent from AliExpress, but I do have hopes of getting this into better use as well for other projects. I know nothing about 3D CAD, but yeah, so I have printed the distance ring, and I will yeah, let's run some B-roll shots of it and see what that looked like. Right, and we're back. And here comes the ring in question. I not have any footage of the 3D CAD design process phase of this, but I used Microsoft's 3D Builder, I think it's called. And it took me a couple of minutes, but I think I learned something. Enough to make this ring, which we can inspect a bit more. Oh, I'm having a little bit of trouble focusing, yeah. So, let me bring some calipers and we shall check what this is. So I have my AliExpress calipers, and yeah, this goes to 15 centimeters. That's exactly how large this 3D printer prints, 15 by 15 by 15 centimeters, so that's 150 millimeters. And let's start off by taking some measurements. So first of all, I have a height of 6 millimeters, 5.96, which was what I entered in the 3D CAD program. So I actually got that accuracy from the 3D printer. And I printed it with the PLA plastic, which I believe is the standard sort of lowest end stuff. It does flex a bit, but that doesn't do anything in our case. 1.6 millimeters thick, which is interesting because I was aiming at 3 millimeters, I believe, but I got like 1.3 or something. So it seems that it isn't equally thick everywhere. Maybe I messed up a bit, so it's a bit more, it's a bit fatter here. 1.6 versus 1.3. Maybe I did something not completely right. 1.4, yeah, but I believe it should fit our purposes. And then of course I've got the outer diameter, which is 102.5 millimeters, and an inner diameter let's see here, maybe I stretched it a bit, 102 or something. So yeah, it's a ring basically. And the idea is now to glue this. Will it fit here? It does. And then okay, let's see how I can place the ring here and gluing it in place. This will be a bit of a challenge maybe, but I think it can be done. So this is the first thing I've ever 3D printed, and yeah, I'm cautiously happy about it. So let me disconnect the USB-C lead for now to get a bit more. Yeah, it actually does seem to fit in here. Let me get some more light maybe into this, if that helps, I don't know. Yeah, and then I will place it, place some hot glue or something here and glue it to this. Or I could of course glue this directly onto the base plate first, and then yeah, either way should work, I believe. So let's get to it. The question is, which glue should I use? Should I use just hot melt glue, or maybe 2-component resin? Maybe I can use hot glue at the bottom here, and then I can use 2-component resin on the rim here. So let me have a think, and we'll get to it. So yeah, let's go for some epoxy. I have some Loctite 2-component epoxy, and just to use this cotton swab stick and apply it onto the rim here all the way around, and then I will sort of place it there and hold it there for a while, until it has set a bit. Maybe that's, yeah. Getting it into place here. Okay, so this didn't work quite as planned. It is not so flat enough, so it doesn't keep it in place everywhere at the same time, really. This bit moves a bit here, and so I'm thinking I will add, now that it sort of holds it in place at least, I will connect my glue gun, hot glue gun, and I will add some hot glue on the inside of here to make it stick better, and then it's from the inside at least, so it won't bulge out on the outer side of the rim here. Hopefully that's the idea, but as far as ideas and reality goes, those are two very close but very distant things indeed. Before we close this up, I haven't actually tested that this cell takes a charge, and that would be a good thing to maybe do before we sort of close the lid on it. Yeah, but you see what I mean. Yeah, this would be pretty nice actually. I think if I can pull this off. So while this is sitting up, I will actually fetch a power bank that we can check the charging parameters. Or actually, I have a USB charger connected here, and if I can we get some lighting over there? Yeah, currently 0 watts. Let's see if we can charge this. So I will connect it here. 4.5 watts. I got a red LED here. It seems to be charging. We have decreased to 3.2 watts. 3.1 watts. So we are pretty rapidly decreasing the charge rate. Very interesting. Let's fetch the power bank with the, or I have the USB tester, of course. One moment. So here I have the USB tester, and if you're interested in this model, look on my channel for the review of it. So let's disconnect that. And have a closer look. So we're starting at 3 watts again, and what's the charge rate like? Let's zoom in. Oh, sorry, that was the wrong. Half an amp currently. So yes, getting some reflection. Can it stay like this? No. 5 volts and oh, 0.47 amps. And yeah, 10 milliamp hours so far. Of course, the battery here wasn't empty, but it does seem to take a charge, at least. It's not hot, so that's good. Oh, but things are happening here. So let's disconnect the charging here for now and try to put some. Oh, this has almost glued into place. Let's try to put some of this on here. So let me just refocus a bit. Maybe I can put some extra light in here. Oh, this light needs a charge as well. I can see. Let's inspect it. I need another light source. This battery was not overly happy, so let's try this one. It has a magnet, but I have nothing to magnetize it to. That's a shame. Oh well. So yeah, I have placed some glue on the inside. And now it sits in place at least. Great. So does seem to take a charge at least, so that's nice. I mean, yeah, let's check the battery voltage at the moment, and then just to see where we're at. I mean, this battery cell does have overcharge protection, it says, so hopefully it will cut off at 4.2 volts unless the circuit board does that. But as we saw with the original battery, it did cut off. But I'm not sure actually if this original battery, if there is there are 2 chips inside of here. Yeah, maybe they were protection chips, I don't know. So it's better to have a battery with protection. Maybe it can cut off then when charging is finished. So let's zoom out a little bit, refocus our attention, maybe place this flat, yeah, put it to volts. Now let's see if I can get a connection here to the positive terminal, because I put some hot glue there. Oh yeah, it seems that 3.325 volts. So why don't we let this 3.325 why don't we let this charge for a bit then? So I will connect it to the charger. Oh. That's a bummer. That didn't hold up too well. That's gonna be a problem for sure. Maybe I can put some of that resin onto this hot glue or something and then press it in there. If it makes a connection, I don't know. Yeah, it was this way around, something like that. Maybe that will work, because it sits pretty tightly on this cable. But okay, so let's try that. I will disconnect the hot glue gun for now, and let's make some more resin then. I hope this resin stuff is okay with hot glue. That it's not gonna dissolve it or something like that. Yeah, maybe something like that, and then I will try to get it inside. Let's see here. So I've put some of the epoxy resin here, and it seems to have settled more or less, and hopefully that will help. But I will also place some more hot glue, I think, once this is finished. Yeah, so I will just I'm out of glue. I need to, yeah, I have a new glue stick here, so I have to feed it in. Yeah, getting some of that in there, and I'll let that cool off for a bit. But if I turn this around, yeah, the USB port is protruding there, and it has a little bit of epoxy around here, so I hope it will stay in place now better than last time. And I will disconnect the hot glue gun once again, and I think that the first charge of this, maybe we should leave it open like this and charge it, just to see that what voltage levels it reaches, and so on. So yeah, I shall hope this is safe too. Yeah, so I will connect the USB lead. So we're at 3.7 watts now, charging at 0.55 amps, but we're decreasing. So that's interesting that it decreases quite fast, at least in the beginning then. And on the battery side here we are seemingly charging. I believe the voltage was 3.325 volts. So let's see what the voltage reading is after a little while. And yeah, 0.5 amps. Let's see if I can get a little bit better angle on this, or move the camera a bit. So we can remove some excess light now. 3.2 watts, half an amp, currently charging. So yeah, let's see what happens after a little while. And we'll leave it like open like this for now, and then once we see that it cuts off at a full charge or so, then we can seal it up. And the question is which glue to use here. I believe that hot melt glue is still the way to go, because then it's more easily serviceable, I think. If I would use some resin, then maybe it will stick very hard to this and I won't be able to access the innards very easily without destroying the ring or so. I will have to print a new one out. I think that when DIYing, things should be, well, at least easily accessible. So 0.48 amps for 9. So I've sort of stopped there for now, but 3.1 watts. But not a whole lot of time has passed so far. So currently only 3 minutes in. Yeah, so let's leave it to do its thing, and we'll see what the status is after a while. So this has been charging for a while now, and more specifically 3.5 hours, and the charging current has increased a bit again to 580 milliamps, and 2150 milliamp hours we have been able to push into this cell. So yeah, we're currently still charging strongly here, so why don't we check the current voltage. .94 volts. So yeah, it seems that the cell is steadily closing in on the hopefully around 4.2 volt cutoff range or voltage level. I can see this 3D printed distance ring sits firmly in place on the charging port. Looks steady enough. So yeah, still going strong, and if this works, I mean 4500 milliamp hours is pretty good. This cell managed to push about 700 or 750 milliamp hours. So it's significantly smaller, and also a charging current of let's see here, 600 milliamp hours or so. Yeah, that's gonna take a while to charge. I mean, the cell wasn't completely flat, and it has already charged for more than 3.5 hours. So it will take a while to charge the cell to 100%, but of course you don't have to charge it to 100%. Maybe I should have a voltmeter or something, like I had on the DIY fan project. If you haven't seen that, then go have a look. The green fan project, I called it. But that, in this case, that would have possibly, ruined a bit of the aesthetics of this lamp. So yeah, we'll continue to let it charge, but it's good to see that it seems to be charging well, and the battery is cool and nice. 600 milliamp hours, 600 milliamps of charge current. At least it won't stress the cell. So since the capacity is 4500 milliamp hours, I mean, at 500 milliamps that would take 9 hours or so, if you have no losses, to charge it. But or slightly faster, so maybe 8 hours, let's say, to charge a cell of this size. So this is it says 16.2 watt hours on it, and the, let's see here, the USB testing device here, it's showing 10.99, so 11 watt hours now. But at least, even though it takes a long time to charge, at least it's not stressing the cell, so it should last many charge and discharge cycles, especially since this lamp is it's only a few LEDs. It's not a very high current draw either. So yeah, but let's allow it to charge on here, and we will inspect it in a little while again. So let's have a look, a closer look. We can notice that we have charged about 3501 milliamp hours and 17.5 watt hours. In calendar time, it's 6 hours and 24 minutes almost, so 6.5 hours. And right now the current is has been heavily reduced to only 260 milliamps. So I would suspect we are nearing end of charge, but let's inspect what the battery voltage is now. So not getting a good connection yet. Yeah, 4.17 volts almost. So we're almost at 4.2 where it should cut off. So basically this cell is nearing end of charge, and yeah, 6.5 hours, and then the cell wasn't completely flat, so perhaps about 7 or 8 hours to charge it fully. It seems about right. So let's see when it actually cuts off, because right now we're yeah, so we have pushed over 16.2 watt hours specified on the battery itself. But of course the charging chip and the circuit board and everything isn't 100% efficient, so I suspect that we have some losses along the way. But yeah, at least the charging current has dropped significantly to about half what we had, or less than half, and hopefully it will cut off at pretty much 4.2 volts. Let's find out in a little while. Alright, so let's inspect this. Some time has passed and the charging process has stopped at 3600 milliamp hours, 18 watt hours, and almost 7 hours of charging. So yeah, and the 7 hours because the charge rate dropped as the cell got closer to being fully charged. So that's all well and good. That we had a cutoff, and we also see that we have a green light now inside here, showing that the charge is finished. Let's therefore inspect the voltage level. So .166, but it started to charge again as I started probing with my leads here. So I suspect that after a full charge the voltage dipped a bit, but it wasn't enough for it to start charging again. But as I started probing around, maybe it triggered it to start again. But okay, I will consider this being fully charged. So let's disconnect the wire, the USB lead, and I have connected my little hot glue gun, and it seems to be almost ready now. As you can see, a droplet forming on the nozzle. And let's try to... This won't be extremely easy, but especially since I keep activating the... unintentionally activating the light, the touch control button. So let me raise this up a bit. Something like that. And I will attempt to put some glue here. I hope I can stay in shot and somewhat focused. I will put my attention for a little while on just putting some glue on the rim here. It's not very easy since yeah, let's see here. I was a bit too late, I believe. It managed to... Oh. Sorry for the... Yeah, I have to be faster, I think, to pull this off, because this glue hardens pretty fast, and also it sticks pretty well to this PLA plastic. Yeah, I got some on me. It was pretty hot, as the name implies, in hot melt glue, maybe. But was this enough to make it stick? Not sure, but there is a section here where I didn't manage to put any glue. So I will maybe try to push some glue inside there. And then press this together. Yeah. I keep activating the light, so sorry for the annoying stuff in this video. But I suppose that's what happens when you deal with stuff like this. Yeah, a little bit more here, maybe. Then squeeze it. Blowing some air on it to make it dry faster or cure faster. Yeah, but otherwise it's pretty enclosed now. I have some movement here, so yeah, I know the edge isn't very nice because I'm using hot glue, but on the other hand, it won't be visible either, because let's say we have the light placed something like this, and if I refocus a bit like that, you don't see the edge. So yeah, there you have it. I suppose I should do an endurance test on this, but maybe we can just extrapolate the numbers a bit instead, because it will be a very long testing. Oh, now I don't remember the numbers from before. Maybe I should look it up. But check the description or the first comment or something for this video. I will have looked up the values we had previously and extrapolated some values. But if we had 750 milliamp hours in this one, in the original battery, And it lasted, yeah, how long did it last? Was it, yeah, I don't remember. I believe it was about 6 or 7 hours, something like that, on this cell, when we started at 250 lux or so. But when we had the worst case scenario, max light output and the mode where all LEDs are lit, both the, because if you remember from part 1 of this series, we have this warm light mode, we have this cold light mode, and then we have all LEDs lit. So in maximum output, with the maximum amount of LEDs lit, I believe we got about, was it 2 or 3 hours or something, before it was too dim to actually be usable in that case. So let's say we got 3 hours, 2 hours, I don't know, 2.5 hours. So yeah, we had 750 milliamp hours divided by, let's say, 2.5 hours. That's about 300 milliamp current draw in that setting with maximum light output. So if we have 4500 in this battery divided by 300 milliamps, yeah, 15 hours. But of course 15 hours is without losses. So we can subtract maybe a couple of hours of losses as well along the way, because I suppose that there's some conversion of voltage from the battery cell to the light, or maybe there isn't. Maybe there's just a resistor or something, and but still power is lost in the resistor. So yeah, but there you have it. It's a nice enough little light. Let me turn off some other light here. Yeah. This is the dimmest mode. They're hardly visible. Yeah, it's a nice nice light. And yeah, the conclusions then. Well, so in its original form, I must say that this battery cell was a bit of a disappointment. This cost about $15-16 US with shipping. Sure, it's metal, but still, this is acrylic plastic. $15-16. They could have put at least twice the size of this cell, like 1500 milliamp hour cell, or 2000 to a 2.6, like a standard 18650 cell. But what I did like was the DIY-ability of it, and that it, despite being pretty simple in its design and such, it works pretty well. It has 3 modes with the warm light. It remembers the mode, like now. It remembered that I had dimmed it down, and I can increase from there. And then the cold light mode, I can increase from there. And the blended mode with both warm and cold LEDs turned on. So the metal finish is actually nice. It looks antique-ish, and the problem was that it wasn't straight. I have tried to straighten it out a bit and it looks fine now. But yeah, the battery cell was a disappointment, and thereby also the runtime. I just felt that it should have lasted longer time before needing a charge. But what I did like was, of course, yeah, the looks of it, simplicity. It still looks nice and it works fine. It makes a nice type of light, and its DIY-ability, because by simply removing this bottom lid here, which was very simple to remove, everything was glued in place, including the circuit board and battery, and that glue was, I must admit, hard to remove. But if you're just patient and go about it, you know, you give it some time and play around with it until the glue lets go, then you have a 750 milliamp cell with the connector, and I did like that. I believe this is a JST 2.0 connector, and also the most of the connections inside the circuit board and stuff also use connectors, so it was easy to remove the battery once you had the glue off of it, taken off of it. So you can order a cheap pack of such cables kit set, pre-mounted, and these connectors are easy to swap the polarity if you want the correct color for positive, negative. So Amazon or AliExpress or whatever, and by using that, and you buy a cheap battery holder, for instance, or just a larger type of polymer cell. Of course, these tend to swell up, of course, and I know the quality of this. But if you buy like a good protected cell, I bought a Nightcore cell, which of course costs more than the lamp itself. Like I paid maybe $20 or something for that 21700 cell. I initially wanted to buy an 18650, but I thought that maybe I can fit a 21700, so I went for that. And as we saw, we ran into a little bit of a trouble with this, because the 21700 cell was too large. But if you buy like a 18650, you can get 2600 milliamp hours or 3200 milliamp hours, I believe, the largest capacity cells in the 18650 form factor. Then you should be, I believe, able to fit that inside, but I haven't tried it. So but instead you can also, of course, go with the route of buying a 3D printer like I did, if you have the means for it and have sought after one for a long time, I suppose. So by buying a 3D printer, I could... My first 3D CAD design ever was this little distance ring. And I tried searching Thingiverse and such for distance rings and stuff, but I realized that, yeah, it wasn't really what I was looking for, and I wanted to try some 3D modeling, and a distance ring seemed like an easy enough geometric shape. And I got a ring, and it actually did fit here, so I'm very pleased with that as well. And then just gluing that distance ring here, basically, and gluing the cell with the holder and the circuit board. I used the extension leads I bought. I ended up using the one with the 90-degree angle on one of the connectors, which was a good idea, but I bought some different types, so you should do that. These were also from AliExpress. These cost a few bucks each, but a few bucks, I mean, for a DIY project, it's, in my opinion, worth it. And you get a fun project for some hours. Now this lamp will stand very steadily as well, because it has a 4500 milliamp hour 21700 heavy cell inside. And yeah, so can I recommend this for a DIY project? Absolutely. Maybe the hardest part was to actually get, yeah, the battery. If you try to fit a larger battery, then maybe will fit here in its original shape, but also this connector, the USB-C, to glue it in place with a good enough glue. It seems that it holds up for now. When I only used hot melt glue, it didn't hold for more than 2 disconnect cycles, but by using some Loctite epoxy, it seems to be holding in place pretty well. And also I glued the used some epoxy on one side of the distance ring, and then I used hot glue, which of course isn't very pretty here, but I did that mainly for the reason that I want to be sure that I can service this in the future as well, so I can easily rip this open. Hot melt glue isn't that strong, and I probably won't ruin the distance ring here if I just take a knife and go about this carefully. But also there is a bit of an overhang here, so when you look at the lamp from above, you don't see the hot melt glue anyway. And I could have used, of course, black hot melt glue, but I don't have any. I should buy some different colors of hot melt glue sticks. That is maybe also a good idea. So yeah, I have personally enjoyed this project very much. I hope you have as well. This is a pretty long video, but it's a pretty nice DIY project too, so I hope you have found the energy and time to watch it for some entertainment and maybe some DIY ideas, who knows. But yeah, thank you very much for watching, and I can see that this channel is growing. Our YouTube family is extending ever so much, little by little, and I'm very grateful for all of you subscribers and viewers alike. So yeah, thank you very much, and happy DIYing. See you in the next video. Bye bye.